Okay, the chances of anyone watching this on December 31st are very low because this is for class and that's the break. Who watches math on their breaks? Maybe some of you, who knows? Maybe someone wants to review some pre-calculus before calculus. I don't know. Anyway, here we are, blah! Look at this picture. It's kind of weirding me out, okay? So we're gonna visualize slope. We're gonna see what happens when we change M? What happens when we change B, right? In this formula, mx plus b, b plus mx, whatever. So m is our slope. Let's look at what happens if we change slope. I have to zoom out so I can get this whole picture together. So let's look at this purple guy. That's just y equals x. If we make this a 2, right? If we put a 2 for our slope, we go from purple to green. Doubling our slope makes the line a lot steeper, right? If you think about somebody walking along one of these lines, you could maybe walk up this purple line, but it gets a lot steeper with the green line with a bigger slope. We make the slope go up to 3. We get that blue line over here. And that's even steeper. You're definitely not, we're rock climbing now, okay? Or if we cut the slope in half, we become the yellow line. Now it's much more navigable. We can walk on it, no problem. So a slope less than 1 makes things flatter, and a slope bigger than 1 makes things steeper. Okay, big slope is steeper, closer to 0 is flatter. And then we have these other lines, right? We have this yellow line as well. Look at the M, it's close to 0, right? It's negative 0.5, if you can read that. Negative 0.5, it's close to 0, so it's flatter. But it's negative, so now we're walking downhill. Okay, if we always think left to right in math, so now we're walking downhill. Going downhill. And then again, when we have a bigger slope, like this is a negative 3, now we're really going really steep downhill. Okay, again, positive is increasing or uphill from left to right. And negative slope, positive m, negative m, that's going to be decreasing or going downhill. We'll use that in some examples in this section. But before we do that, I want to look at the effects of m. This is much more pleasing to look at. These are a bunch of parallel lines. We talk about that more in a later video. These all have the same slope. What's their slope? mx. If you don't see an m, just an x, remember that 1 times x is just x. So all of these have a slope of 1. Now, if we have a plus 4, that's our b value. It starts at 4, right? It starts at 4, just right here. And now in the green, well, now we only start at 2 because the b value is 2. So all of these just start at different ones. We have different parallel lines. The b value is the y-intercept. Or we could say it's the vertical intercept. We'll talk more about intercepts in a later video as well. Let's get some practice. Let's do some matching. Which line goes with which function? So let's go backwards. Instead of really trying to match, let's see what each of these functions are going to look like and then choose the right one. Okay. And I should have provided like letters. Let's call this A, B, C, and D. Just because not everyone can distinguish colors as well as everybody else. Let's use some letters. Should have done that in the previous ones too. All right, this first one, 2x plus 3. What do we know about that? We know the slope is positive. And it's, I don't know, medium steepness. Right? If we think about, let's compare all the slopes, right? 2, 2, negative 2.5. Let's say medium steepness. We know it's going up, so it's increasing. And we know it starts at 3. So it should have the point 0, 3 on there. So now we look at our graphs. Okay, so these 3 graphs have the right starting value. Red, blue, and yellow. A, B, and D. The green one, letter C, that's out. That's not possible. Well, let's look at the slope of these. Red one could be it. Blue one could be it. Yellow can't be it. Why is letter D, the yellow, not okay? D is decreasing. Decreasing. Ha! So it can't be it. So we know, right? We know it can't be D. We know it can't be C. Must be A or B. Well, let's look at the slope. We know the slope is 2. And by the way, I should make this comment earlier. 2 as a slope, rise over run, we can write that as 2 over 1. It should go up 2 and right 1. So you see if we go up 2 and right 1, we're on the blue line. We're letter B. Okay? So this is indeed letter B as our answer. Or you can answer blue. Yeah, anyway, let's move on. Letter G, going to be very similar. The y-intercept is -3. Oh, we're done. We know it must be line C. We can double check. Yes, it has the right slope. Yeah, we already know it's going to be letter C because that's the only one that with a starting value of -3 with a vertical intercept of -3. Let's look at H. So H has a starting value of 3. We know it can't be B or C because we already did those and this is a different equation. And it has a negative slope. We know it must be decreasing. Well, which ones are decreasing that start here? It's just D. All right. So this has to be D. Oh, C for green. D for yellow. And lastly, we know the last one should be A. But let's just double check. Has a starting value of 3. Good. A has a starting value of 3. And the slope is 1/2, which means up 1, right 2. Or down 1, left 2. Good. It does indeed have those. We know this is indeed letter A. A for apple, which can be red. All right, that's example 3. Hopefully that answers your questions on how we can use slopes visually and intercepts visually to kind of get a picture of what something's going to look like. In the next one, we'll do some more algebra on how to find the intercepts without the graph. Whoa! All right, that's forced enthusiasm. I don't think it's that exciting, but hopefully it won't be painful. Think about it like a trip to the dentist. You don't need it to be good. You just don't want it to suck that bad.